This is question 7 on the target about computer algorithms. Jack is learning about computer algorithms, and he comes up with a new idea for how to sort a sequence of distinct elements into increasing order. During each step, he randomly picks two adjacent elements and switches them into increasing order if necessary. If necessary, that's important, before checking if the entire sequence is now in order. If the sequence is in order, then Jack performs no further steps. That's also very important. Jack starts with the sequence 3, 2, 1. Given that each step fully takes 1 exact second, compute the expected number of seconds it takes for his procedure to finish sorting the sequence into increasing order. So for this situation, it's important to so it's not like a chain. So Sprint 21, the one about the coins, it was every single expected value could be sort of treated as a chain where one leads into the other, right? But in this case, this is more similar to a Markov model where each expected value of each state depends on first of all, the emission at that state, plus the probability that another state, it transitions to another state, plus the expected value of that state. So what we can start doing is we can just define our states or define what, just to make some easier notation here. We say we're at state A when the sequence is 1, 2, 3. Say we're at state B when the state is 1, 3, 2. And we can just keep going like that. C is going to be 2, 1, 3. D can be 2, 3, 1. That's not a D. There we go. E can be 3, 1, 2, and F can be 3, 2, 1. And we're looking for E of F, right? Starting here, we know that since A is already in sorted order, our algorithm wouldn't even take a step, and it would just have an expected number of seconds to work as 0. Now, we want to do is we want to find E of F, so we should write an expression for that. E of F is, well, it's 1 second to perform the operation, right? And then it either flips these two, 3 and 2, in which case would take us to state D, and that's a 1/2 chance to select that pair. So that's 1/2 E of D. Or I could flip the other two because these are also out of order, and that would take us to state 3, 1, 2, which is E. And that's also 1/2 probability that happens since it picks randomly. That it is not a 1/2. 1/2 EF. Then let's find ED next. ED is equal to 1 plus, we pick this first pair. Since they're in order, we wouldn't sort that. So that would just become 1/2 times the expected value at our same state. We're looping back to the same state. And otherwise we would flip this pair. So that would take us to 2, 1, 3, or state C. Since ED is in both sides, we can subtract this ED over, which would give us 1/2 over here, multiply by 2 to get ED in terms of just EC. ED is then equal to just 2 plus EC. Moving on to state EE, or the expected value at state E, it's going to be 1. And looking at E, we either flip 3 and 1, so it's 1, 3, 2, which is state B. So that's 1/2 to get to state B. Or we don't flip these two, in which case it's just 1/2 to state E again. So this, again, simplifies in the same way that D simplified to just EE is equal to 2 plus EB. Now that we have, okay, then there's one last state we need to do. We need to do EC, which is 2, 1, 3. If we flip this first state, or first we have 1, we either flip these first two to 1, 2, 3, in which case that's A, and we're already done sorting, so we wouldn't take any more steps after that. Or we wouldn't flip these two. Wait. Oh, state C. Yeah, so we would either flip these two and be sorted, or we would not flip these two. So that would take us back to state EC. So solving this one out, we see that EC is just equal to 2. So on average, if you're in state state C, it'll take you on average 2 seconds. Then now we found EC as a constant number, so we can just go back up and we can solve everything else out. EE, that's EC. Oh, we never wrote the statement for EB either, so we should do that too. EB, 1, 3, we wouldn't sort that, so that's 1 plus 1/2 of 0. Or we wouldn't sort that, so that would become state EB. Plus, and then this other state, we would flip that, and that would become our sorted state, so that's 1/2 times 0. So EB is also equal to 2. And that kind of makes sense, right? Since you would only need to sort 2, it's either you'd sort it into sorted order or you wouldn't, and you would just keep looping that until you did sort it. So then finally, now that we have these, we can figure out EE and ED. Those are just 4. EE equals 4, ED equals 4. And then finally, for EF, it's just 1 plus 2 plus 2. So the expected number of seconds our algorithm would take to sort from the state 3, 2, 1 is 1 plus 2 plus 2, which is equal to 5. All right, that's all I got. Thanks everyone for listening. I appreciate it.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.